Graham walks 8 blocks from his home to the library. He always walks 4 blocks east and 4 blocks south. So we're going to draw a diagram, a city grid of this. Okay, on which corner is his house and which corner is the library? That's a city grid looking from the top. It's a map. Where would his house be? Where would the library be? They're going to be in opposite corners. So, house, library here, library, house, library, library, house. What's going to be, is it going to be top left or top right that I should start with? Top left. At top left is going to be house or library? House. So if this is the house, this would be the library. Nice. Okay, so here we got house and library. And he always walks 4 blocks east and 4 blocks south. So, for example, he could go this way. 4 blocks east, 4 blocks south, and get to the library. Okay? Now, I want you to count them as I do them. Okay? So that's one possibility. Can you see that this is a different route? And then he could go this way, or this way, or this way. I haven't counted that one, or this one, or this one, or this one. That one, that one, that one. Have I got them all yet? How many were we at? 14? Oh, good. Okay, so this could be complicated because before long, your paper might be all full of green and you don't know if you counted them all or not. So that option 1 seems like not a good idea. Option 2, that sounded bad, didn't it? Option 2, you could draw them all out separately. So you could draw one, then redraw your grid, and then draw another one, and redraw your grid, and then draw another one. Okay? That also is not going to be very fun to do because that could take a long time. Now, this is in the identical objects section, so we have to figure out how is this an identical objects question? How could I represent this as a name? Right? And the answer is easy. If we make all the easts E's and all the souths S's, can you see that the path that I just drew is easy? Yes? I mean, you could also have, right, what was the very first route that we took? East. And that would be a different route than easy. How could we figure out all the routes possible? Well, if we thought of this as an identical objects question, once we've represented it, well, normally it would be 8 factorial if they were all different directions, but we have 4 easts and 4 souths. For some reason, I think, no, 70. Oh, man. 70 different ways. So we can count this question as a Mississippi question. Another way that this question is sometimes done is if we start counting the ways to different intersections along the way, we get the following. For example, how many ways can he get to that corner? Now we're also assuming that Graham is an intelligent being, and he knows where the library is, and he knows where his home is. And this is not one of the paths that he takes on the way to the library. I'm going to the library, I'm going to the library, I'm going to the library. Oh, where's the library? I am so lost. Oh, there it is. Right, we are assuming that Graham is smart and he knows the direction he needs to go to get to the library, but he has 70 different options of the way to get here based on the streets that are there, right? I live close to school. If we do the same thing for me walking to school, I have 2 different paths. I walk every day to school. I'm like, ooh, which path should I take today? It's not that exciting. This would be, it would take me longer if I lived as far as Graham does from the library. It would take me longer to walk to school, so that would kind of be bad. But I would have all of these different options. Anyways, so we've got 70. Another way that we can look at this, assuming that Graham is quicker, how many ways can he get to here if he's not going to backtrack? 1 way. That's pretty straightforward. Okay? Same thing down here, you'd agree that that's 1 way as well. What about this one here? There's only 1 path to get to there. He just has to go in that straight line. Any other pathway that he takes to that spot would cause him to backtrack. And so all of these along here, can you see that they'll also be 1s, 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 right to that corner? How many ways, how many paths are there to this one right here? 2. Because he could go either this way or this way. What about the next dot over? This one will be 3. And this one will be 3 as well. Now, this one will be 4, and this one will be 5, and this one will be 4, and this one will be 5. How many ways are there going to get to this one? And once you figure that one out, you might be able to figure out every other dot after that. Sorry? There's more than 4. There's less than 9. 6. So I see that you use 2 strategies, the 4 and the 9. Well, the 9 actually didn't work for this number here, but the 6 does. What number is going to be here? 10. So someone's figured out the pattern. And what number is going to be the last one, Erwin? Okay. $15. So if there are 5 ways to get to this corner and 10 ways to get to that corner, does it make sense that there's 15 ways to get to that new corner? Because you can either go the 5 ways or the 10 ways, and then you get to your new corner 15. So if we did this all along, well, this will be 10, 5 and 10, this will be 15, 10 and 10, this will be 20. This one will be 15 and 20, 35, 20 and 15, 35. And we get 70, same answer as before. So these walking questions sometimes come up like this. And sometimes they add special things to them. So Graham, for example, Graham wants to go to the library, but for some reason now, he decides to always walk past Sally's house. So now how many ways can Graham get to the library if he's always going to be walking past Sally's house? Can you see that he will never go to these sections now? Because if he went to any of those sections, he wouldn't be able to walk past Sally's house without backtracking. And similarly, he will never go to any of these sections. So if he's going to walk to Sally's house on the way to the library, it sort of breaks it up into two rectangles. So how would we solve this question? Well, we could break it up into two and say there's two decisions that need to be made. We have to first count how many ways from his house to Sally's house. House to Sally's house. Can you see that in order to do that, you would need 3 e's and 2 souths? 3 easts and 2 souths to get from his house to Sally's house? So that would be equal to 5 factorial over 3 factorial 2 factorial, which is 10. That's the first section. And the second thing, he would have to go from Sally's house to the library. In order to do that, he would need to go east once and south twice, which is 3 factorial over 2 factorial, which is 3 ways. So if there are 10 ways to get to Sally's house, and then 3 ways to get from Sally's house to the library, how many ways can he get to the library if he has to go to Sally's house first? It's not 13, because this is now a decisions question. How many decisions does he have to make? He has to make 2 decisions. A decision from his house to Sally's. How many choices does he have? 10 choices. And then he needs to make a decision from Sally's house to the library. How many choices does he have? 3 choices. So he has 30 choices. Now, for more reasons than just one, but for the reason that Sally knows that Graham always is figuring out how many choices he has for his route on the way to the library, she thinks that's a little weird, so every time he walks by the house, she hides. It's probably a good strategy. So we've got 30 ways. So we could count this one as decisions. There's 2 decisions that need to be made. How many choices does he have to get to Sally's house? How many choices from Sally's house to the library? There's going to be 30 in total. We could also do the counting ways as we move along. So this would be 1, 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 this would be 2, this would be 3, this would be 4, this would be 3, 3 plus 3 is 6, and 6 plus 4 is 10. So things are good up till we get to Sally's house. Now, how many ways are there to get to here? What did we do before? We always added up the 2 corners, right? So to get to this 10 would be 6 plus 4 is 10. But now how to get to this one is 10 plus, there's no corner above. There's like nothing up here. So does it make sense that this is going to be 10 as well? And this will be 10, and this will be 10. 10 plus 10, this will be 20, 20 plus 10, 30. So we could get that 30 counting that way as well. So here's a slight adaptation combining the identical objects with the spaces, and this is where this unit starts to get difficult because we get to start combining strategies together by adding Sally's house. I've seen this same question done where they add like a big lake. So now when traveling, you're restricted in which ways you can go. Then the counting technique that we used is probably the best strategy. Okay, questions for this one are number 12.